One word, typed twice, silently turned off encryption for millions of Apple users. Not a hack. Not malware. Just one line of code, accidentally copied, and it sat there, wide open, for over a year.
And the wild part is that everything looked fine. Your iPhone showed the little padlock. The connection said secure. But behind the scenes, the check that guaranteed that security was being skipped entirely.
Right. This is the story of goto fail, probably the most famous 2 words in security history. And it's a perfect example of how a tiny, boring detail can quietly break something massive.
So let's set the scene. February 2014. Apple pushes out an emergency security update, totally out of its normal cycle. And when researchers dig into what got fixed, they find something almost embarrassing in its simplicity.
To understand it, we need to talk about what happens when your phone connects to a secure website. That padlock isn't decoration. There's a whole handshake happening in milliseconds.
Exactly. When you connect over HTTPS, the server sends your phone a certificate, basically an ID card saying I really am your bank. But an ID card is worthless if you don't check the signature on it.
And that signature check is the whole point. The server proves it owns a secret private key by signing part of the handshake. Your phone verifies that signature against the public key in the certificate. If it matches, you're really talking to your bank. If not, somebody's impersonating it.
So the signature check is the door lock for the entire encrypted internet. And the goto fail bug? It quietly unlocked that door and left it hanging open.
Let's look at the actual code, because it's almost hard to believe. Apple's SSL library had a function that verified that signature step by step. Each check, if it failed, would jump to a cleanup label called fail using a goto statement.
So you'd see a line like, if this check fails, goto fail. Then the next check, if this one fails, goto fail. A whole ladder of them, one after another.
And here's the mistake. In one spot, there were 2 goto fail lines in a row. Same statement, typed twice, stacked right on top of each other. Just a duplicate.
Now normally you'd think, so what, running the same jump twice does nothing, right? The second one never even gets reached. But that's the trap, and it comes down to how C treats an if statement without curly braces.
This is the crucial bit. In C, if you write an if statement without braces, only the very next single line belongs to that if. So, if it fails, goto fail, that first goto is controlled by the if. It only runs when the check actually fails.
But the second goto fail? It's got no if in front of it. It's indented like it belongs, but the compiler doesn't care about indentation. To the compiler, that second line is unconditional. It runs every single time, no matter what.
So walk through what that means. The code reaches this point having passed earlier checks. It hits the first goto fail, which is skipped because nothing failed. Then it hits the second goto fail and jumps straight to the end.
And the line it jumps over? The most important one. The actual final signature verification. The step that says yes, this server really proved it owns the private key. Skipped. Never runs.
Then it gets even sneakier. When the code jumps to fail, you'd expect it to return an error. But because of how the logic was written, the error variable was already set to 0, meaning success.
So the function jumps to the failure handler and then reports success. Every certificate with a valid-looking structure gets waved through, even if the signature is completely bogus. That's a total collapse of the trust check.
Which means an attacker on the same network, a coffee shop Wi-Fi, a compromised router, could present their own fake certificate for your bank, and your phone would accept it. Classic man in the middle, and the padlock still shows up.
They could sit in the middle, decrypt everything, read your passwords, your messages, and re-encrypt it so nobody notices. The encryption was technically still on. It just wasn't protecting you from anyone.
And this shipped. It went out on iOS and OS X and lived in the wild for something like a year and a half before it was caught. Millions of devices, quietly vulnerable the entire time.
So the obvious question, how does a company like Apple miss this? And the answer is uncomfortable, because on the surface the code looks totally normal. Your eye reads two go-to-fail lines and thinks, yeah, that's cleanup, moving on.
That's what makes it so instructive. It wasn't a genius exploit. It was probably a bad copy-paste or a botched merge. The kind of thing every single developer has done. It just happened to land on the most sensitive function in the stack.
And this is where the coding style becomes the villain. If those ifs had used curly braces, the duplicate line would have been harmless, it'd sit inside or outside the block clearly, and the logic wouldn't break the same way.
There's also dead code detection. A decent compiler warning would have flagged that the real verification line was unreachable, nothing could ever reach it. That warning existed. It just wasn't turned on.
And unit tests. There was apparently no test that fed the function a bad signature and checked that it got rejected. Everyone tested the happy path, good certificates work. Nobody tested that bad certificates fail.
That's the deepest lesson, honestly. Security code isn't about proving the right thing works. It's about proving the wrong thing gets blocked. And that negative test is the one teams skip the most.
So you get this stack of small, ordinary failures, no braces, no warnings enabled, no negative tests, a routine copy-paste, and individually none of them is a disaster. Together they left millions of people exposed.
And that's really the point. Big outages and big breaches almost never come from one dramatic mistake. They come from a tiny error slipping through a series of safety nets that all happen to have a hole in the same spot.
So next time someone tells you curly braces or compiler warnings or writing failure tests is just nitpicky style stuff, remember goto-fail. One duplicated word disabled encryption for millions of iPhones. Style is security.